So in the last video, we just started to introduce the concept of refraction. Now with everything in physics, there's going to be some math attached to it. So we're going to start to look a little bit at the math, and this is going to extend for a little bit of time. So refraction, the mathematical relationship was developed by a Dutch mathematician named Willebroord Snell. And what Snell had figured out, and you don't need to know you don't need to prove this or anything. What Snell had noticed is that the sine of this angle of incidence divided by this sine of the angle of refraction, this was equal to some constant value. So what he ended up figuring out, and again, you don't need to prove this, is he figured out that that ratio of the sine of the incident angle to sine of the refracted angle, that was just actually equal to the ratio of the indices of refraction for the refracted medium over the incident medium. Now, we're probably going to ditch the subscripts I and R, just because R can be confused instead of refraction, it can be confused with reflection. So we're just going to use the numbers 1 and 2. So like 1 for medium 1, 2 for medium 2. So what Snell had figured out is that this sine of theta 1 over sine of theta 2, this was equal to n2 over n1. So the main thing that we want to watch out for here is, you'll notice I have 1 over 2 with the sines, but 2 over 1 with the indices of refraction, so be really careful with that. So another way that we could write this, if we didn't want to write it in fraction form, we can write it as n1 sine theta 1 equals n2 over sine theta 2. So n1 is going to be our index of refraction of our incident medium, n2 is going to be the index of refraction of the refracted medium, our second medium. Again, our indices of refraction don't have units. Theta 1 is going to be the angle of incidence in degrees, and theta 2 is going to be the angle of refraction also in degrees. So with that said, because we're using trig functions, calculator in degree mode. So this equation, it's known as Snell's law. This takes into account index of refraction and angle. We're going to expand Snell's law a little bit later to include things like wavelength and speed, but we'll get to that a little bit later. So this equation here, this is on the data sheet. It's not on the data sheet in this form, so you would have it presented like this. But let's look at a couple of examples of Snell's law just to see how it applies. So we have yellow light. It's going to travel from air with an index of 1 into a 24-karat diamond, which has an index of refraction of about 2.42. So the light rays, they're instant on the diamond surface at an angle of 28.5 degrees relative to the normal. So we want to find the angle of refraction as light enters the diamond and the speed of light inside the diamond. Alright, so let's see what we got going on here. So we have light. So I'm going to just draw this sketch here. So bear with me. Not a great sketch. But this is going to be my air and my diamond. So we're told that the light ray is coming in at about 28.5 degrees. And what we'd like to find is we'd like to find the angle of refraction. Now, because we're going from a medium of an index of 1 to 2.42, this is going to go into a higher index medium. We know that the light ray is going to bend towards the normal. So this is going to be our angle of refraction here. It should be smaller than 28.5 degrees since it's bending towards that normal. We want to find out how much it's going to bend. So in this, we know N1 is air. We know N2 is 2.42. We know theta 1 is 28.5 degrees. So we'd like to find what is theta 2. So for us, we're going to use Snell's law. So we know that sine of theta 2 over sine of theta 1 is going to be n1 over n2. Now in the data sheet, you'll notice that it's sine theta 1 over sine theta 2. I flipped that, so if I flip the left side, I'm just going to flip the right. As long as I have 2 over 1 here, as long as I have 1 over 2 here, I'm okay to do that. But you can do the long rearrangement if you so please. So I can say that sine of theta 2 is just n1 over n2 times sine of theta 1. And we can calculate that. So we know n1 is just 1. We know n2 is 2.42. We can plug in sine of 28.5 degrees. So what this is going to give us for sine of theta 2, well, this is going to give us, let's see here. This is going to give us about 0.1972. but this is just sine of the angle. I would like the actual angle itself, and since I'm using sine here, I need to take the inverse sine, so that's second function sine on my calculator. So what is this going to give me now? Well, this is going to give me about 11.4 degrees. So based on the information I have here, I can say that the angle of refraction is about 11.4 degrees. So light's going to come in at 28.5 degrees relative to the normal, and then it's going to refract in the diamond with an angle of about 11.4 degrees relative to the normal. And then part B, we want to find the speed of light inside the diamond. So we know that the index of refraction is just the speed of light in a vacuum divided by the speed in the medium. We're interested in finding V. So V is just going to be the speed of light in a vacuum divided by the index of refraction in this medium. So we're going to have our 3 times 10 to the 8 meters per second divided by 2.42. And what we're going to get is we're going to get about 1.24 times 10 to the 8 meters per second. So when light's traveling in the air, it's going at 3 times 10 to the 8 meters per second. When it enters the diamond surface, it's going to slow down. It's going to go at about 1.24 times 10 to the 8 meters per second. So it has slowed down quite a bit, but keep in mind, it's still going really fast. Like, it's still traveling on that order of 10 to the 8 meters per second. The last question that we want to look at here, this is a common diploma type question. Now, I have to do it the long way because in my haste of getting all my stuff before the pandemic really took full swing, I forgot to bring my protractor, and I don't have a protractor at home. So I have to show you the long way to do this, which is good. It helps if you don't actually have the protractor. But I also recommend on a diploma exam, bring the protractor. It's really helpful because a lot of questions now, they want you making the measurements. So we got a ray of light. It's going to travel from an unknown medium into air as shown below. So we got our unknown medium, we have our air. Now, what we need to do is we need to make measurements because we need to find the index of refraction of the unknown medium. Now, I don't know why it says second medium because it should say first. I guess like I said, I always seem to catch typos and forget to fix some of them. Now, we know from Snell's law, we know that sine, so I want the first medium, so I know sine theta 2 over sine theta 1 is equal to n1 over n2. This is what I know from Snell's law. n2 we know is air, so we know that directly. This is what we are trying to determine. Now, I don't know theta 1 and theta 2. What you would actually do to do this really quickly, you would actually measure this with a protractor. But the big thing is you're measuring relative to the normal line. So for example, this angle here, that's theta 1. This angle here, that's theta 2. It's relative to the normal line. As I said, I don't have my protractor. So if you don't have a protractor, you have to do the next best thing. You have to use Sohcahtoa. So let's see, I know my side opposite and my adjacent. So let's see how long this is. Like I said, we're doing this kind of the long way and it's slightly less accurate. So I know this side's about 2.5 centimeters. And I know this side here, oh, what do we have? So it's like between 3 and 3.1. So I'm going to say it's about 3.05 centimeters. So that covers me for this. Now for this second ray, oh, I don't really have a lot of guidance because I also have to figure. Well, actually, I know the. Oh yeah, I'm gonna have to figure out. I'm gonna have to try and draw something like this here. Like I said, this is not particularly accurate, but we want to at least get this distance here, which is, in my case, it's about, we'll call it 3.4 centimeters. And then this distance here, if I measure it, it's about I'll say 2.4 centimeters. So what you'd actually be doing if you didn't have a protractor like I do, you want to maybe measure the legs of your triangle, and then you're going to use the inverse tangent to find that angle. Because I know if this is my opposite and adjacent, this would tell me, the inverse tangent would tell me that angle. So based on my calculation here, if I do the inverse tangent, I'm going to get about for my calculations, so I'm going to just kind of do this over on the side here. So theta 1 is going to be the inverse tangent of opposite and adjacent. So the inverse tangent of 2.5 centimeters divided by 3.05. So this is going to give me about 39.34 degrees. As I said, this is not the best way of doing it. A protractor would be more helpful, but it is what it is. Same thing with theta 2. I know this 3.4 opposite, I know this 2.4 adjacent, so we can also use the inverse tangent to calculate that. This is not my preferred method, but like I said, the pandemic has taught us to do things a little differently, so I'm going to live without a protractor here. So if I do that, we'll get about, let's see here. That does not seem right at all. That seems way too big. I will go with it. So I'm going to get about 54.78 degrees. That's what I'm getting, but let me double check that. I feel like that number's okay. No, that seems right, and yeah, no, it is what it is. So I'm going to go with those numbers. So now I have my angle of incidence and my angle of refraction. So for my equation over here, I know that n1 is equal to n2 times sine of theta 2 over sine of theta 1. So I'm just going to plug in my values of theta 2 and theta 1 that I got using my Sohcahtoa rules. So I have this 54.78 degrees divided by sine of 39.34 degrees. So what am I going to get for this now? So I am going to get, hang on here, it's a real slow going process. So I am going to get about 1.29 for my index of refraction. So for me, I'm going to say N1, it's about 1.29. Now for a question like this, with the computers, when they design this question, they can get an exact answer for this based on like having exact measurements. They're going to give you a range, like a tolerance of where they're going to expect your answer to be. So like I got 1.29. Maybe if I change, like if I said that was 3.3 instead, I'll get a slightly different number. For questions like these where you're taking measurements, they will expect a range of answers. They're going to give you a tolerance. So don't be afraid if you do something like this that you get a slightly different answer. You'll probably get a slightly better answer if you actually used a protractor. I had to do something a little bit different just because I don't have a protractor with me. So I had to do it a little bit more old-fashioned than the long way. It's not wrong. It's as you can see, it's more work. Whereas if I had a protractor, I could have measured those in less than 30 seconds, got that number. But the pandemic has taught us something. We can adapt quickly.